Welcome everyone. Welcome to Karthikeya IAS Academy. So till last session we have talked about earthquakes, volcanoes, the continental drift theory and all. So with respect to continental drift theory, we have seen that there are few criticisms with respect to Wegener's theory. So though they able to understand the drift is happening, though we were convinced with the evidences like zigzag, fossil evidences, glacial striations, etc., that drift was happening, we couldn't figure out why the drift is happening, the reason behind the drift. So in in that thing, we ended up talking about something called post drift studies, right? We talked about post drift studies in the last session. So in that post drift studies, we came up with something called your convectional current theory and plate tectonic theory, right? The convectional current theory was given by Arthur Holmes. So he actually was a geologist. So he said that whenever there is an activity happening within the asthenosphere, so if you take your crust like this, your crust part, and then you have your mantle, the upper mantle, so together we call it as lithosphere, and in the bottom part you have a layer called asthenosphere, right? Asthenosphere. So in the asthenosphere, what happens is radioactive minerals were present there, and they undergo several chemical reactions, and they'll hit the crustal part. Creating a vent, and later they'll break the crustal part, or sometimes it may hit the crustal part and will be moving in this direction, right? So if you take your crustal part like this, according to Arthur Holmes, here is the asthenosphere. So according to Arthur Holmes, what he says is, in the asthenosphere we were observing something called the radioactive things forming. So when they raise up like this, they may not hit the surface, but they turn like this and creates a circular cycle form here. Similarly, if the same thing happens in the another part, there also we observe cycles being formed. So like this. So these are nothing but your convectional currents, and when you observe the midpoint of two cycles like this, and like this, so here if you observe, both the things were converging, right? And here the plates were diverging, right? So due to the radioactive activity, the magma is rising and creating a conventional current, or a current which gives a divergence at one point of time and convergence at one point. See, at one place if it is diverging, it is obvious that another place, if the other converging point is coming, the both will converge like this. So whenever convergence happens, a trench will be formed. A trench is nothing but a deep shallow hole, or deeper hole, not shallow hole actually, deeper hole, due to the tectonic activity. And if divergence happens, the magma comes out like this. See, we have seen in volcanic activity, right? So in this way the convergence and divergence happen. So if you observe this video here, so this is how a conventional current happens. See, if you observe the orange part which is coming from inside that is the asthenosphere layer, or the mantle in that case, and the thin layer which is above the earth, which is blue in color, is your crustal part. So crust actually lies between some 5 to 30 kilometers of width, and later you have your mantle, the upper mantle and lower mantle. So between it we have asthenosphere, right? So this conventional current happens in your asthenosphere only, and the down part, which is very red in color, so this part is nothing but your core. So if you observe from the middle part, from the core part, it is raising like this, and then it is turning like this and creating a conventional current, right? Here somewhere around you will be having another conventional current being seen. So here you observe convergence, and here if you observe, this part is diverging, right? So the other Ohm's theory of conventional current gives a basis for something called creation of tectonic plates, which is nothing but your plate tectonic theory. So if you observe this video again, see the conventional current is diverging the plate boundary which it is hitting the surface, and then if you see the sides, the right and the left sides, it is converging like this. So if you observe this end part, it is converging like this, right? So if you see, this thing is converging and here it is diverging, right? So you need to have a clear-cut understanding what happens during convergence and what happens during divergence with respect to your conventional current theory. So with the conventional current theory basis, Harry Hess have came up with something called your plate tectonic theory. He says that all the continents were nothing but the tectonic plates over the earth. So if the earth is circular in shape like this, all the continents, you have several continents here, right? Several continents like this. All the continents were having several plates surrounded, and they were separated with several plates, is what the plate tectonic theory says. If you see this, observe this diagram. So if you observe, this is your North America. This is your North America. The whole thing comes under the North American plate. So this whole thing is North American plate. So this whole thing is North American plate, and this is South American plate. If you see the Eurasian plate here, the Indo-Australian plate, Philippine plate, Pacific plate, Arabian plateau and African plate. Similarly, the plates were still being formed due to convergence and divergence phenomena and conventional currents. And if you are able to connect the continental drift theory now, the reason which was given by your Alfred Wegener is the drift is happening due to something called a polar fleeing force, which is not a right thing. But if you observe now, it is conventional currents under the earth which is responsible for the creation of several plates on the continent, and these plates were drifting because of the divergence and convergence phenomena, right? So if you observe here, there are something called major plates and minor plates. So major plates and minor plates are differentiated based upon their expanse and the length. So major plates, the major plates are nothing but your Eurasian plate, North American plate, South American plate, Indo-Australian plate, Pacific plate, African plate. If you observe this diagram again, see the Indo-Australian plate is wide, your Pacific plate, North American plate is having big expanse, South American plate, African plate, Eurasian plate. Alright. So when this Eurasian plate is hit by your Indo-Australian plate, that is a place where our Himalayas were seen. So because of the plate tectonic activity, in the conventional currents we have observed, right? What happens during the convergence? The plates will converge like this. If divergence happens, it will diverge like this. So due to the convergence phenomena between the Eurasian plate and our Indo-Australian plate, the Himalayas were being formed. And if you observe the minor plates, there are several minor plates like Nazca plate, Scotia plate, Cocos plate, Caribbean plate, right? Like this you have several minor plates being there, and there are some micro plates also, like which are little more less than the minor plates, like Panama plate, Persian plate, Sunda plate. So these are micro plates, right? So these are major plates, minor plates and micro plates. And why are these plates were forming? Because of the conventional current. Previously, if you observe, you have your crustal part like this. But if you have a crustal part, continuous crustal part, and there is some conventional current activity, these two will be separated. One becomes 1 and 2. So this is nothing but one plate and this is another plate. So similarly, due to the conventional current, we have formed so many plates like this, major, minor and micro plates. So under the Harry-Hess theory in the plate tectonics, he have given that till now we have observed 3 kinds of plates in particular. They are nothing but the divergent plates, convergent plates and transform plates. Your divergent plate is nothing but if you have a plate like this and if they diverge from one point of time, from one area, if they are diverging or moving opposite directions, that is nothing but a diverging plate. Converging plate is nothing but if you have a plate like this and if both the plates are converging. Converging means coming together, diverging means going far apart. So this is convergence and divergence. Like that, the transform plate is nothing but if the plate is moving in this direction, the another plate moves in this direction. So if you have 2 plates like this, transform plate means like up and down will be happening, like transform will be happening. So this is nothing but a transform plate. So if you observe the divergence phenomena, in the conventional currents also we have observed that the magma from the asthenosphere rises up. So it gets separated like this, it forms mountain kind of structures here which are nothing but mid-oceanic ridges. So if you take this divergent boundary diagram, in your previous thing you have seen that asthenosphere will have radioactivity and it blows out, mantle plume comes out. So mantle plume. Why I am stressing this word? Because in your previous year questions, main question, there is a question about, like it is in 2018 I guess, you have a question about mantle plume. What is it mantle plume and how it is responsible for plate tectonic theory, etc. That was a question. So you have to be familiar with the terminologies too with respect to geography. So mantle plume comes out and it forms something called ridges over here which are nothing but oceanic ridges or mid-oceanic ridges. So in your volcanoes you have seen types of volcanoes in which we have talked about mid-oceanic ridges there, right? So mid-oceanic ridges are those which forms during the divergent plate boundaries. Alright. So if you observe this divergence, it will be somewhere converging at some point of time, right? So there you can observe the convergence again. So if you see this African plate, or in divergence, I forgot to tell you that in divergence there were several stages. When a plate is diverging, first it forms a fault, like if the plates are like this, it creates some fault, and then a rift valley will be formed, and then if the plate gets diverged totally, there will be a formation of linear sea. Understood? So this is the stages of your divergence, and if you see here, this is a lithospheric plate which is undergoing divergence. So a rift valley is formed here. Mid-oceanic ridges are formed here. From asthenosphere, the mantle plume comes out. And if you observe your African plate, the present day African plate is undergoing divergence. It means there is some conventional current activity which is observed within the plate and which is responsible for the divergence. So this is called as East African Rift Valley. I've told you, right, in divergence there are several stages. First it forms faults, and then it forms Rift Valley, and then linear sea. So a East African Rift Valley we call. So in this East African Rift Valley, what happens is your Nubian plate and Somali plate, the Nubian plate, and this is your Somali plate. So both Nubian plate and Somali plate gets diverged, and it is forming something called East African Rift Valley. So over a period of time, what happens is, if you observe the arrows here, the Rift Valley gets separated and it forms a fault, and then it forms a Rift Valley, and then it goes on forming a linear sea. And over a period of time, you can observe that this Rift Valley will be diverged totally, and there will be a sea which can be seen. There will be a sea which can be seen between the Rift Valleys. So at the same point of time, if you observe your African and Saudi Arabian plate also, previously they were together, and after that there was divergence happened, and then that African plate and the Saudi Arabian plate also. So if you take your African plate like this, if you take your African plate like this, and then your Saudi Arabian plate, previously they were together, they drifted and formed something called Rift Valley, and then a linear sea, which is now we called as Red Sea. A linear sea will be formed in the later stage of divergence, right? So in the East African Rift Valley, what is happening now? It is happening a Rift Valley here, and later it will also turn into a sea. And now present your Red Sea here is nothing but a sea which is formed due to the divergence between African plate and the Arabian plate. So this is how divergence happens. And in the later concept, we should talk about something called convergence, because when a plate is diverging at one point of time, it will be converging at other point, right? So if you observe the convergence like this, you can have. So when two plates were converging, or when two plates are approaching together, what happens is one plate will move like this, the other plate will move above. So this is nothing but your continent and continent convergence. Himalayas is the best example for your continent-continent convergence. There are several types of convergences, like continent-continent might converge, ocean-continent might converge, continent-ocean also converge, ocean-ocean converge, etc. You have several convergence phenomena. But if you ask me, what is a plate which goes down and what is a plate which goes up, whichever is the denser one will goes down or subducts. We call this zone actually as subduction zone, right? And the denser plate will always subduct. Remember, the denser plate always subducts, and the lighter plate will be slided towards or slided above, and it will form something called mountains like this. It may be volcanic mountains, it may be any kind of mountain. And here, due to the convergence phenomena, what happens is when one plate is coming like this and the other plate is like this, there will be a V-shaped trench formed. So here if you can, it is not mentioned clear, but there will be a trench being formed here. And that is the reason why you have to remember that during convergence what happens, you will have mountains and trenches, and during divergence you have mid-oceanic ridges, right, or rift valleys or linear seas, etc. So these are the landforms associated with the divergence phenomena. And then if you see the convergence here, this is the lithospheric plate. So this is the lithospheric plate and it is another lithospheric plate. Both were converging together, and here there will be a trench being formed. If you know Mariana Trench, which is like a deepest part in the earth, like Mount Everest in Himalayas is the highest one. Similarly, Mariana Trench is the deepest point on the earth. So this Mariana Trench was formed due to the convergence between the Pacific plate and Philippine plate. So these trenches and mountains are the landforms associated with the convergence phenomena. And if you observe, this is how a convergence phenomena will take place. See, if you observe here, that part is converging and this part is moving above. See, if you observe, this part is converging, right? So this part is converging. It means it is the denser plate and lighter plate is going above. So both together were forming this mountain ranges and trenches here. So if you observe the video again, see, one plate is going down, one plate is going up. These mountains were formed, and the other phenomena which you can observe is the volcanic thing, or the magma is rising here like this. So it is nothing but in convergence you have the formation of volcanic islands, and you also can see here how the convergence is taking place in ocean and continent scenario. This is the oceanic plate and this is a continent plate. If the convergence happen between ocean and continent, you will observe trenches and also the volcanic mountains, right? This is all about convergence and divergence. And then later you should be talking about transform plate boundary. I told you, right, if there is a plate like this and another plate like this, if they are moving in opposite directions like this, like touching each other, if they are moving in opposite direction, we call that boundary as transform boundary. So this is a continental crust, this is another continental crust. So if you observe its direction, this is like this and this is like this, right, in opposite directions. So if you could observe, see how it is happening. The transform boundaries will have a right and left movement. We call it as synstral and dextral movement, which is nothing but left and right. That's it. Synstral is left, dextral is right. So this is how a transform boundary actually moves.
Excellent.
So after convergence and divergence, we need to talk about transform boundaries. So I have told you, right, about transform boundary. It is nothing but if you have a plate like this here and another plate like this here, if they move in opposite directions, we call it as transform boundaries. So if you observe here, this is one continental crust, this is another continental crust, this is another continental crust. So if this moves in this direction and this moves in opposite direction, you observe something called transform boundaries, right? See, we call this as synstral and dextral movement. Synstral is nothing but your left side movement and dextral is nothing but right side movement, right? So if you see this video, you can observe how these two continental plates were moving, right? So they were crossing out to each other in opposite directions, right? So this is how a transform boundary would be. And example for this is John D. Fuca plate near the California with your North American plate. So John D. Fuca plate with North American plate. So these are example for your transform boundaries, right? So now we have actually seen what is divergence and landforms associated with it, convergence and transform, right? So if you take your atlas and if you observe, there are several identification marks to mention the divergent, convergent and transform boundaries. So your task today, after completing the session, what you have to do is you take out your atlas, and then in the last pages of your atlas you will be having something called the plate tectonics. In that you will be having a different plate boundary maps like this, and if you go through it, you'll have a marks like this which represent divergent boundary, because what I said, in divergent you'll be seeing faults, you'll be having rift valley and linear sea, right? So these are the stages which will be seen during the divergence phenomena. And sometimes this divergence also lead to the formation of ridges or mid-oceanic ridges, right? This is the divergence symbol, and if you see convergence, you'll have your mountains like this and trench like this. So this is a symbol for convergence. So this was actual notation. You might have different symbols too with respect to your atlas. And then for transform boundaries, you'll have a symbol like this, right? So now your task is to identify what are the major plates, minor plates, and what is the consequence happening between those major plates and minor plates. And with respect to convergence, we have seen this thing, right? So we have seen how convergence happens, right? So like this it will happen. So this is a convergence phenomena seen between the ocean and the continental crust. But if you see a convergence phenomena between continent and continental crust, I have told you in your major plate thing that this is your Indo-Australian plate. And this is your Eurasian plate, right? Indian plate and Eurasian plate, right? So if you observe this video, see how both the things were converging like this, right? So this is how the Himalayas have formed. Because of the convergence phenomena between both the continents, what happened? It tend to the formation of something called Himalayas. And because still the Indian plate is moving still beyond its convergence activity, we can still observe your Himalayas being growing over a period of time. So Indian plate is moving and moving upward, and it also creating the height of the increasing the height of your Himalayan ranges, and that is the reason why recently the height of the Mount Everest was reviewed, and it was no more 8848, it is much beyond this 8848. It is something around 8850 and or 49, I guess. Right, before it was 8848, but now it is 8850 meters, right? So just because of the tectonic activity, these mountains are growing, right? So this is all about your convergence, divergence and transform boundaries. And now if you observe your Eurasian plate and Indian plate being converging, if you observe this video, first you'll have your Eurasian plate like this. Gradually the Indian plate will move and the present Himalayan belt will be formed at this point after the convergence scenario, right? Let me play this. So 60 million years ago, what happened? See, if you see here, subduction of the lithospheric plate is happening. So here in the image, this side part represents your Tibetan plate or Eurasian plate, and this part represents your Indian plate. So you can observe Indian plate and Eurasian plate here. So 10 million years ago, what happened? The ocean floor, it has subducted. I've told you, right, when it is convergence happens, one plate has to subduct. So it was subducting, and see how the Indian plate have hit the Eurasian plate, and it created something called Himalayas. So if you observe this video, so over a period of time the Indian plate have struck and it has formed sediments, and now our India is in this position, right? So now it is in such a way that the Himalayas are still growing, and even in future the Indian plate will much go beyond the limit and can also lead to other climatic and other scenarios which take some millions and millions of years of time. If you see our India map, if you see your India, right? So here you have Himalayan ranges, right? All this is Himalayan range, and then you have something called Greater Himalayas, Lesser Himalayas and Shivaliks, and you have Great Northern Plains. So you have this called, you name it as like Babbar and Terai region, and then you have something called your Deccan Plateau region here. So over a period of time, if the Indian plate further moves, all this mountain range, so due to the mountain only we have, due to the formation of several ranges of mountain only, we have something called Greater Himalayas, Lesser and Shivaliks as of now. But later, even beyond Shivaliks, there will be another mountain range being formed, another mountain range being formed. So over a period of time, if the Indian plate structures more and more ranges of mountains will happen. So in the basic landforms thing, we have talked about what is called a range, right? A continuous chain of mountains. So a cordillera is nothing but parallel ranges. So similarly, after millions of years, there might be a cordillera being formed in our Indian subcontinent, right? So this is all about your conventional current theory and plate tectonics. In the further classes, we'll be discussing about the geomorphic processes, and then we'll see the landforms of different types, like desert landforms, karst landforms, glacial landforms, etc. Thanks for attending the session. Thank you.